Start with this letter I problem right here. And again, it's going off of what we did yesterday. So this girl, Kathy, races on a bicycle with 13-inch radius tires. When she's traveling at a speed of 44 feet per second, how many revolutions per minute are her wheels making? Okay, what is the measure or what's the units that we have to start? What information do we have to start? What speed is she going? Good. We're going feet per second, and we want to be in what units? Minutes, what per minute? Revs per minute, revolutions per minute. Good. Okay. So I'm going to start this out, and then if I need to do work off to the side to help me fill anything in, I'm going to do that. So I'm going to start with that 44 feet per second. So I've got 44 feet per second. And if I'm doing my railway, I'm just going to keep my little, just put my little marks on. If you don't like the railway, I still have to do fractions. So I'm still going to do 44 feet per second, but then I'm going to multiply something next so that I can get rid of that. So I'm going to start, can we get rid of seconds and get into minutes? What am I going to multiply to get rid of that seconds? Good, 60 seconds over 1 minute, good. So then my seconds cancel and I'm in minutes, which is good because that's what my end goal is. So I've done seconds to minutes. Now I've got to work to get to feet to revolutions. Okay, remind me, what did we say was the same thing as a revolution? The circumference is going all the way around. So 1 revolution is equal to the circumference. So we got to figure out what my circumference is. Circumference is pi d or 2 pi r. Which one do I have? Do I have r or d? R. I've got r, I've got 13. So it's 26 pi or approximately 81.68. And that r was in inches, so my circumference is in inches. The unit that I'm going to use in a minute, the conversion factor I'm going to use in a minute is 1 revolution equals this 81.68 inches. So at one point, I'm going to have either the 1 revolution on top and that 81.68 inches on bottom or vice versa. So I can get that revolutions in. I don't think I'm ready to do that yet because do I have revs or inches on my problem yet? No, I've got feet. Can I get feet into inches though? Yeah. Oh yeah. How many inches are in a foot? 12, good. Is that 12 going to go on top or bottom? 12 inches on top, 1 foot on bottom. Okay, so my feet are canceling out. Can I now use that conversion factor we were just talking about? Yeah, we're immediately now ready to do that. My inches, though, needs to go on the bottom. My 81.68 inches needs to go on the bottom so that it cancels out with the inches on top. And it's related to being exactly 1 revolution. Do I need to keep going or is that what I want? That's what we want. We're done, right? Now we just have to put all this in the calculator. We have revolutions on top. We've got minutes on bottom. That's what we wanted. So we're good to just put in the calculator.
So we're going to do 44 times 50 times 12 times 1 divided by 81.50.
And you don't even have to do times 1 divided by. You can just do divided by that. So I'm going to do 44 times 60 times 12 and then just divide it by.
What decimal place do you want to start?
Let's go 2 places. When we're doing like trig stuff.
You sure how you got 81.6 at the end?
That was my circumference.
26 pi.
And so that gives me the answer of 387.86 revs per minute. So that means that her bike tire is turning over 387 times in 1 minute. That's a lot of minutes. She's moving. All right, that's it. Are we feeling a little bit better now that we've done a couple of these? Okay, we'll try and do it either next class or in the near future just so we don't lose this. Okay, the next thing that we're gonna do, I'm actually gonna try and find a blank part of my notes. I'm actually gonna move this, I think. Down here. And I'm gonna use this area of my notes, and I'm gonna do essentially a little review of some trigonometry that you learned back in geometry. Do you guys remember SOHCAHTOA?
Yeah.
Nice, okay, that's what we're doing today. So I just made a little box off to the side. You can put this wherever you want. If you don't like where your notes are right now, you can put it on your unit circle, as long as you just write down or at least listen to what I'm gonna say, okay? So we are doing SOHCAHTOA. SOHCAHTOA, SOHCAHTOA. And I'm gonna start by drawing a triangle on here. If you remember when we did trig before, or when we did SOHCAHTOA, we had to use right triangles. I also don't need my calculator, so I'm gonna get rid of that. I'm gonna use a theta as my angle. I introduced it yesterday, and I'm just gonna keep using theta. If you like using X, that is fine too, but I'm gonna put a theta in here. That's the angle that I'm looking from this corner. And from then, we're gonna label our opposite, adjacent, and hypotenuse side. Where's my hypotenuse?
Long side.
The long side, the one across from the 90 degrees. Where's my opposite side? Is it the vertical one or the horizontal one? The vertical one. It's the side that is directly opposite my angle. And so if you don't know where your opposite is, go to your angle and draw a line to the side across from it. And then last but not least is my adjacent side. So that just is the last side over here. This side over here is my adjacent. Okay. Now, when we did SOHCAHTOA, we just had 3 trig functions that we used. Today, I'm going to teach you 3 more. So I'm doing a little chart now because I'm going to do my trig functions. And we're going to start with the 3 that you guys know, okay? We're going to do sine, cosine, and tangent. So I've got sine of theta, cosine of theta, and tangent of theta. That's messy. Okay, everybody good so far?
Yeah.
I just made like a note off to the room. Okay. So if I look at my shape, do you remember what my sign is? Is it O, A, H? Which combination? What order? What is sine? O over H. Good. O over H, which is why we write so. What's cosine going to be? A over H. Good. And then last tangent is O over A. These are my ratios that happen when we're doing our trig functions of sine and cosine and tangent. I taught many of these to many of you this a couple of years ago. We were kind of remembering this a little bit. If you say no, my feelings might be a little hurt.
No worry,
Thank you so much. Okay, now I'm going to teach you something new. Now we're going to talk about the reciprocal functions. When I say reciprocal, what does that mean to you? We flip them, right? So now I'm going to tell you about our reciprocal functions. And I'm going to put them in a certain order, okay? And these letters we saw earlier this week, and I was like, you don't know that yet, okay? The first one is going to be CSC theta. The second one is going to be SEC theta. And the last one is COT theta. Okay, and these all have special names. The first one, CSC, is cosecant. Cosecant. Say again.
We need to know like this full name, and usually like the abbreviation.
You will never have to write the full name out. You really just have to write the abbreviation, but I'm gonna use like cosecant, secant, cotangent. And I promise you in like a few days, you will just know those because we just use them enough. So cosecant, and cosecant is the reciprocal of sine. So if sine was O over H, what is cosecant gonna be? H over O, very good.
You sure we did?
I don't think I taught you this. So I'm not saying you didn't learn it. I just don't think I was the one that taught you this. Does anyone know what SEC means? Jason's been waiting all day to make that joke. It means secant. So I said cosecant a minute ago. This one is just secant. Now you may in your head want cosecant and cosine to go together. Notice that cosecant and cosine are not next to each other. Sine goes with cosecant, cosine goes with secant. So that's something that you may just have to work around in your head. What is my, if cosine is A over H, what's secant gonna be? H over A. And then last, what do you think COT stands for? Cotangent, very good. So cotangent is gonna be the reciprocal of tangent. And so tangent was O over A, we're gonna do A over O. All right, we are going to use these all day today. We are going to go down to the next part, and we have 4 different triangles that we are going to find the missing side for. We are going to find all of the trig functions for after we find that missing side. Can I move on to that first question? Okay. Now notice that I've got my little theta over here. Can you tell me what's my hypotenuse on the first triangle? 5. Good. What's my opposite? 2, and then it's my adjacent. It's just blank. I don't know this. Does anyone know how I could go about finding what that side is?
A squared plus B squared equals C squared.
Amazing. A squared plus B squared equals C squared. Some Pythagorean theorem. So we're gonna do A squared plus B squared equals C squared. Now I only care where C is. Where does C come from? C is the same thing as your H, your hypotenuse. I must have hypotenuse. A and B don't really matter as long as one of the other sides is A and one of the other sides is B. So I'm going to jump over to the side and I'm going to say 2 squared plus B squared equals 5 squared. So 4 plus B squared equals 25. I'm going to minus 4 from both sides. B squared equals 21. And then we'll square root that and we get B equals the square root of 21. If we could simplify that, we'll simplify it, but we can't simplify root 21. Yeah. On this case, no, because we are looking at a real triangle and it cannot. Oh, you're going to hate me in a couple days about this. In this example right here, this is a real triangle and real shapes have positive sides. In a few days, we're going to have shapes with negative sides. Again, I just said, I know you're going to hate me. But right here, this is a normal triangle. The sides are positive, so we do not need a plus or minus. That is an awesome question, Demaya. I literally was answering that and I was like, they're going to be so mad. It's not hard, but you guys are going to be mad about negative sides in a few days. I'm not, I promise it's not hard, but it's just different. It's weird. We're not used to negative sides. Okay, wait, now we've got all of our sides. Can we do sine, cosine, tangent? What's my sign going to be for this shape? Good, O over H, which is going to be 2 over 5. Cosine is going to be what? A over H. So root 21 over 5. And what about tangent? Tangent is going to be over A, which is 2 over root 21. Now, I do not want any radicals in my denominator. So if we need to rationalize, I do want to rationalize it. But I like having written that first and then rationalizing it from here. So I'm going to multiply by root 21 on top and bottom. And my final best answer will be 2 root 21 over 21. Okay. Those are my answers so far. Now, in order to find cosecant, secant, and cotangent, you can just take the one that it's next to, and I lined it up on purpose next to each other and just flip it. So cosecant is the reciprocal of sine, so it's going to be 5 over 2. Secant is the reciprocal of cosine, so it's going to be 5 over root 21.
5 root 21 over 21.
Very good. 5 root 21 over 21. Don't be afraid to write it unrationalized first. I don't want you to worry too much and rationalize it in your head and mess something up. So write it unrationalized and then fix it. And then cotangent, and this is why I had you write it unrationalized on the last one, is I want you to take that 2 over root 21 and just flip that, then there's less work. So it's going to be root 21 over 2, and that's the best answer there. Okay. Hey, do you think you can try the next one on your own? All right, feel free to talk to a neighbor. I'm going to put it on the board, but try the next one on your own. Before you start doing your sines, cosines, tangents, I want you to check your O, A, and H. And I want you to check and make sure that your missing side is the same as mine. Once you feel good. I don't think you can simplify root 34. Really. We will rationalize when it's time. Yeah. All right, I've got letter B's answer on the board now. I've got my rationalized sine and cosine. Everything else did not need to be rationalized. And then I took all my reciprocal functions and I flipped them.
That's why.
Yeah.
So do we need to be putting these in the calculator?
Nope.
No, we just throw a fraction.
The calculator is going to come in a couple minutes. We got 2 more problems like this. Does anybody have any questions so far? Are we ready to start the next one like this? Am I moving too fast? Okay, I'm good. Okay. I'm just going to help you start the next one just because it's set up a little bit differently. So the first 2 that we did were triangles drawn. They were set up. They were labeled. We just went from there. On number 2, it says, given one function, find the others. And I have sine, cosine, tangent, cosecant, and cotangent are all blank. But it does give me a ratio for secant. Can you remind me, secant is what over what in terms of A and O and H?
H over A.
H over A, very good. So that's my H and that's my A. Do I have a triangle already drawn off to the side on this one?
Yeah.
Oh, amazing. So I'm gonna go label my hypotenuse as 3 and my adjacent as 2. My hypotenuse 3. I'm sorry, what? Oh, I can't also do my cosine. Yeah. So Eileen's saying I know that it's just a reciprocal of secant. And so you can immediately go do your cosine right now. I'm going to do this first. I'm going to label my sides. I've got 3 and then 2 is my adjacent. And while I'm here, I'm going to label hypotenuse, adjacent, and opposite. What do I need to do next? Pythagorean theorem, good. Find that missing side. We want to know what that opposite side is so that we can find all of my trig functions. All right, before you do any of your trig functions, make sure your O, A, and H are all labeled. Make sure that missing side is found. And then go find sine, cosine, tangent, cosecant, secant, cotangent. All right, and then I've got my answers written up here. Check out the board when you're ready to look. Anybody questions yet? Okay, on that next one, it's almost the exact same, but you have to draw your own picture.
What's the thing for,
You sure? Okay, I'm gonna come down here. Letter B is the same idea. This time they only gave us tangent. What are my letters for tangent? What over what?
over A?
O over A, good. So I do need to draw my triangle, and I want to draw it just like the other one was drawn. So give us a little coordinate plane. X and Y axis. I'm going to draw that triangle right here with the theta being right at the origin and that 90 degrees being on the x-axis, just like the one above us is drawn. And I do want to label my opposite as 4 and my adjacent as 5. And I'll label opposite, adjacent, hypotenuse. And then we'll find our missing side and then find all of our trig angles. So again, I'll be quiet for a second while you do that. All right, again, feel free to check in on your triangle before you do sine, cosine, tangent, all that fun stuff. I've got my missing side. I've got all my sides labeled O, A, and H. Then plug in and find all of your trig functions. Again, check the board when you think that you have them. Make sure you're matching with me. Did I answer any questions? How are we feeling so far today? We're feeling pretty good? Yeah. It's pretty easy, right? You guys are rocking it. I want to jump a little bit. Surprise, surprise, I want to jump around in our notes. I want to go to number 4 where it says evaluate with a calculator. So I told you to get your calculators out. Now is where we're really going to need it. We already did a little bit of 3. We're going to do more with that in a second or tomorrow or whatever. But I want to do a little calculator eval because it's not hard, but it is very particular. And I want to make sure that you are practicing each stroke with me. So again, if you don't have a calculator, I like using this phone or iPad app called Calculate 84. So feel free to do that. If you don't have a real calculator, it's the same setup as your real calculator. But I want you physically pressing all these buttons with me. And I'm even going to suggest you write everything that I write so that you plug the right thing in as well. Okay. So we are going to go to our calculator and we are looking at these problems right here, these 6 right here. Now, as you know, there are 2 different ways that we measure angles, right? We have degree and we have radians. Can you tell me which of these A through F are degrees? Which ones are degrees? A is a degree. What else? Okay. Anything else? That's all. Everything else is a radian. And I know that because they don't have degree signs and because 2 of them have pi's. F is just because it doesn't have a degree symbol. It must have a degree symbol if it's a degree. So I have mine marked as degrees and radians. The yellow ones are degrees, the green ones are radians. It'd be really easy for me to be like, okay, we're going to do all the degrees first and then we're going to do all the radians second. No, we're going to keep intermixing and we're going to go switch back and forth and back and forth. Does anyone know how we switch between those 2? Yes, if we're converting, but I don't want to convert. I just want to switch to my calculator. There's a button I want to press to go between degrees and radians. It's mode. If you press mode, I'm not sure what mode you guys are automatically on. I would guess degrees. But we're going to start on letter A. So I want you to be in degrees if you're not. So make sure that you're marked on degrees. Press enter. If you were in radians, definitely not what we want. Once you've pressed degree, press second mode to clear out and just go back to our main page. Now we're going to do secant of 10 degrees. Do you see a button that says secant on here?
Wait, yes. No.
I don't see secant anywhere. Can you remind me, secant is the reciprocal of which one?
-1, so
It's not cos -1, but it does go with cosine. It's going to be 1 over cosine. Cosine to the negative first, we're going to deal with in a few chapters. That's if I put in a number here, like 1/2, and I got an angle out here. My answer would be an angle. But I'm putting in an angle, and I want a decimal or an answer out. So I'm going to do this 1 over cosine. While we're here, what would cosecant be? That's 1 over which one? Sine, good. And then what about cotangent? That would be 1 over what? Tan, very good. And if you remember, somebody last period was like, oh, that's literally what we wrote in our notes. And we're on the other page. But yeah, I made you write. Oh, I guess I didn't make you guys write that. I did a better job with C period. I'm going to do a better job with you guys. What I would maybe do right now, or I'd maybe flip back and I'd come over here and write, why don't you write this? Okay. I'm going to write cosecant is going to be 1 over sine of theta. So on our little chart that I made you write, we just went h over o. I would maybe make it 1 over sine. Same thing for secant. We're going to make that 1 over cosine. And then last for cotangent, we'll move that O and that A over O over, and we'll make that 1 over tangent theta. That way you will have that in your notes now. All right, that's right. We recovered from this mistake. I'm so sorry. But what we're gonna go do on our other page where we were at, I'm gonna physically write down just so I know what I'm gonna put in my calculator. Secant is gonna be 1 over cosine of 10. We changed our mode to degrees a minute ago, and if you forgot or if you just want to double check, you can hit mode and make sure your degree is highlighted. So I'm going to press 1 divided by cosine, and I'm going to put 10 in parentheses, and I'm going to press enter. That is my answer. 1.0154. Let's go 4 places after the decimal here. Yes, right. I put 1 divided by cosine of 10 in the calculator. 1 divided by cosine 10. Enter. You get what I get? Perfect. Okay. All right, the next one. Am I still in degrees or do I need to change to radians? Still in degrees. It's okay, still in degrees. We didn't change. That's all that matters. What I do need to do is I can't put degrees, minutes, seconds in my calculator, so I need to make this 11 minutes into a decimal. Do you remember what we do to 11 minutes to get it into a decimal? Divide it by 60. Very good. 1 degree over 60 minutes. The minutes cancels, and 11 divided by 60 is going to be 0.1833. So we'll just leave that at that. If we had seconds, we'd have to convert that too, but we don't. So now that I made my minutes a decimal, I'm going to take my 28 degrees and my 0.1833, add those together. So just kind of tack them next to each other. And I'm going to do tangent of that. So we're going to put in the calculator tangent of 28.1833. Tangent 28.1833, enter, and I get 0.5358. If you notice, now we hit a radian, so we got to go change our mode to radians. Does anybody have any questions before I change to radians?
Wait, so we don't divide it?
Don't divide what?
We don't do 1 over 10, whatever.
Nope, this is a normal tan.
Oh, okay.
So that's just a normal tan, so we just press the tan button. Okay, before I do anything for the next one, I'm going to go to mode and I'm going to go back to radians. So hit mode, make sure your radians is highlighted. Second, quick to get out of it. Now it says cosecant. There's no cosecant button, so what are we going to press? 1 over sine. And we are physically going to type in 5 pi divided by 16.
So it doesn't matter that the pi's
Doesn't matter. It's all going to work itself out. So when I do 1 divided by sine, I'm just going to go 5 pi divided by 16. It's going to multiply 5 times pi, and then it's going to divide by 16, and then it's going to do the sign of that, and then we're going to do 1 over that answer, and we get 1.2027. That was a harder number. Am I moving too fast, or are we good? Okay. Letter D says cosine of pi over 9. Do I need to be in the same mode of radians or do I need to change it? We're still in the same. We're still in radians. And if you need to check, just hit mode. Okay, I'm still in radians. We're good. Cosine of pi over 9. I'm just going to literally press cosine pi over 9. So cosine pi divided by 9. I have nothing to write here because I didn't do anything other than what it literally told me to do. So 0.9397. Now we're going to jump to letter E. So that one's degrees. So we need to go to mode and go to degree, press enter. clear out. You need to make that inch from minutes to degrees, so that 18 minutes, just like we did a minute ago, we're gonna multiply by, or 1 pi, or 1 degree divided by 60 minutes. 18 divided by 60.
This way.
What's that?
We're doing seconds. Or is it only for like the, was it like DMS things? That's the only time that you would take the seconds by 60 instead of 3600? Is that the only time you would do that?
When you're going from a decimal to seconds, that's the only time you do it. Since we are going from seconds to a decimal, we are gonna divide by that 3,600.
Okay.
Mhm. And so I get 0.0036 degrees. And we dealt with our minutes, we dealt with our seconds, so we're gonna add the degrees that we have together. 129 plus 0.3 plus 0.0039. And if it makes you happy, you can throw it all in the calculator like that. Or 36, excuse me. And so I'm gonna do sine of 129.3036. And I can just write that straight in my calculator, right? Sine 129.3036. And I get 0.7738. And then my last one is cotangent of 2. What mode should I be in for that? Radian. So go back to mode. I think we need to change it to radian. And how do I type in cotangent in my calculator? 1/tan2. And I got a negative. We have not gotten negatives yet, but negative is a totally legit answer. So negative 0.4577. I'm sorry, none of our examples had that so far, but that is a real answer.
But what was it? This is usual, or is that regular degrees?
When we're doing what?
If we're just regularly doing our math, we're working on rating the degree.
I would say generally you use degree more, but I'm gonna tell you in the next couple of weeks, you're gonna use radians probably more. So if you're resetting your calculator, I'd probably put it back to degrees for now, because I know some word problems next class will have some degrees. But in a few weeks, we'll go to radians kind of for a while. Okay, I'm gonna turn this off.
What?